Alright, today we have adding and subtracting like fractions. So when the denominator is the same, that's what it means to be like fractions. Your fraction is a part of the same whole. Your denominator is the whole piece. So when the whole is the same, you're just adding the parts. So that's why you add the numerators only and you keep the denominator. That is the biggest mistake. Students want to add the denominator, but you're not adding different wholes. You're adding the same part of the same whole. All right, so simplify if necessary. So for example, A over C plus B over C, if you look, the whole is C. It's an A part out of C and a B part out of C. Add those parts together. It's the same whole. It's the same with subtracting. All right, you're subtracting B from A from the same whole. So a couple examples here. So if you look at the first example, I have 7 parts out of 10 plus 6 parts out of 10. So how many parts out of 10 do I have? It's 13 out of 10. All right. If you want to simplify that, 13 divided by 10 is going to give you 1 3/10. The second one, it's the same thing, this time just with the integers. I've got 5 parts out of 8 plus negative 7 parts out of 8. So how many do I have altogether? Well, add the top row. 5 plus negative 7, all right, is basically 5 minus 7. It's going to give you that negative 2 out of 8 parts. And if we simplify that, then it's negative 1/4. It's the same with subtraction. 3 parts out of 10 minus 9 parts out of 10. How many parts do you have? Well, 3 minus 9, again, don't tell me it's 6. 3 minus 9 is going to give you negative, oh, darn it, forgot my pen again, is negative 6 over 10. And if you simplify that, both are evens, divide by 2. You're going to get negative 3/5. Same thing for part D, 5 parts out of 15 minus 10 parts out of 15. So what's 5 minus 10? Don't tell me 5. 5 minus 10 is negative 5 out of 15. And then if I divide by 5 on both sides, it's going to give me a negative 1/3. Alright, so when you add mixed numbers, there's 2 methods, 2 different ways you could do this. The first method is you could add the whole numbers first and then add the fractions. If you want to separate it, go for it. The second method is to change the fractions to improper fractions and then add. So let me show you what happens when you use method 1, when you just add the whole numbers first, and then you add the fractions. So 2 plus 3 is 5, and 3/8 plus 7/8, 3 parts out of 8 plus 7 parts out of 8 is 10 parts out of 8. Does it look strange? You've got a mixed number and an improper fraction. So what you need to do is you need to break apart that improper fraction. If you take 10 divided by 8, it's 1 2/8 or 1 1/4. So now you've got to add that to the 5. So it's actually 6 1/4. All right, so some of you guys might think, oh, there's kind of an extra step there. There might be. If your fractions turn into an improper fraction where it's top heavy, all right, you might have to convert it and then end up adding your whole numbers. But either methods work. Let me show you method 2. If you convert everything, 4 times 1 is 4, plus 3 is 7/4, and then 4 times 4 is 16, plus 3 is 19/4. And then if you add them, 7 plus 19 is 26/4. And then if you divide that, I'm just going to do my work up here, 26 divided by 4, 4 goes in there 6 times, with 2 out of 4, oh with 2 out of 4. That's my dog. I'm sorry. Hang on. Okay, he's gone. So 6 and 2/4, which is actually 6 and a half. All right. So yeah, there's a couple extra steps by doing the mixed numbers, but then you don't have to convert and then add to the whole number. All right. But either methods work. You use what you like. You use what you are comfortable with. So now subtracting mixed numbers. Method 2, changing them to improper fractions. Method 2 is the easiest way to subtract mixed numbers. The reason why, look at example A. If I did 5 minus 1 and got 4, great. But then I've got 1/8 minus 7/8. Now I can't do that anymore. Then I've got to borrow from the whole number and then add the 8/8 to the 1/8, and it's a little trickier. It might just be easier to do method 2. Just change them to improper fractions and then multiply. So I've got 8 times 5, which is 40, plus 1, so that's 41/8, minus 8 times 1 is 8, plus 7 is 15, and then we can just subtract. So this gives us 26/8, and then if you did the work, I'm just going to squeeze it in right here. 8 goes into 26 3 times, with 2 left over, so it's 3 1/4. It's a lot easier than borrowing and adding the 8/8 to the 1/8 and all that. Okay, so method 2 might be easier. So again here, 3/4, you can't take 3/4 from 2/4, so we're going to do 4 times 2, which is 8, plus 2, which is 10, and we're going to subtract 3/4, and that's going to give us a nice easy 7/4. And then 7 divided by 4, 4 goes into 7 one time, with 3 left over. That is a 3, by the way. So it's 1 3/4. It's quicker to change them. All right, so that would be my suggestion, but that is certainly not the only way. All right, last thing I want to talk about is evaluating expressions. So evaluate x minus y when x is 3/5 and y is negative 4/5. So we're going to substitute what we have here. So the first one is x, so x is 3/5, and it's minus y, which is negative 4/5. Now don't think, oh, I already put the negative. No, you didn't. It's subtraction, so you definitely need that subtraction, and then it's a negative 4/5, so you need both of them. Now think about it. When you subtract a negative, you are really adding. I told you these rules are not going away. So 3/5 plus 4/5, 3 parts out of 5 plus 4 parts out of 5 is going to give us 7 parts out of 5. And how many times 5 go into 7? With 2 left over. So our answer is 1 2/5. Okay, so we're going to spend a bit of time with the evaluating expressions tomorrow. All right, I will see you then.